Okay, good morning, and thank you to everybody who's joined us today for our webinar. So our latest webinar is on the importance of certification for hazardous area equipment. So just to introduce myself, I'm Charlotte Loudon, Raytech's Marketing Communications Manager, and I will be hosting today's webinar. I'll be joined by my colleague Jonathan Somerset, Raytech's Technical Manager, who will be running through the main bulk of the webinar today. Just some things to note. We'll be doing a Q&A session at the end of the webinar, so please submit any questions that you have into your GoToWebinar control panel, and we'll come to them at the end of the webinar. And then just to note, the slides and the recording will be made available after the webinar, so you can watch that on our website. So now I'll hand over to Jonathan Somerset.
Okay, thank you, Charlotte. Thank you for that introduction. And yes, I'd also like to welcome you to this Raytech webinar on the importance of hazardous certification in hazardous area equipment. So through this webinar, we're going to be providing a brief introduction to hazardous areas, as well as an overview of gases and vapors, dusts, and hazardous area classification, before moving on to product certification, standards and markings on hazardous area equipment. And then we will then take a look at self-certification before closing on choosing the correct luminaire. So, introduction to hazardous areas. So first of all, we need to define what we mean by a hazardous area. So a hazardous area can be defined as an area in which an explosive atmosphere may occur in quantities such as to require special precautions to protect the safety of workers. So that could be special precautions for construction, installation, as well as the use of equipment. Such areas can often be found in industries such as oil and gas production, refineries, chemical production sites, and food production. So these industries require hazardous area equipment, including lighting, and it is important to know where and why this type of lighting is required. So why is hazardous area equipment required? So equipment, including lighting, needs to be purpose designed for use in hazardous areas to prevent an explosion from occurring. To understand this further, we need to look at the three components that must all be present for an explosion to occur. So the first is a flammable substance or fuel in the form of a gas, vapor, or dust. The second is oxygen. So as we all know, the air that we breathe is around 21% oxygen, and so that provides ample amounts of oxygen when mixed with fuel to form an explosive atmosphere. And the last thing we need is an ignition source. So there's 13 potential sources of ignition, some of which being hot surfaces, flames, mechanically generated sparks, static, straight currents, all of which can provide an ignition source for an explosion. So together, these three components make up what we call the fire triangle. So all three must be present for an explosion to occur. Take any one of those components away and an explosion cannot happen. So when we talk about specially designed lighting equipment, we're usually removing the source of ignition from the fire triangle. When we talk about dust explosions, two further components are required. So as well as fuel, oxidant, and ignition source, you also need confinement and dispersion of dust to make up the dust pentagon. So this can be in the form of a dust confined by a building structure and dispersed among the air within the building, forming a potentially explosive dust atmosphere. So why EX lighting? So explosion protected lighting, this means that the luminaire has been designed to prevent the source of ignition and to prevent an explosion. EX lighting is often required for many areas throughout the site, including internal manufacturing areas, clean rooms, internal and external access, as well as storage areas. So one example here that we've presented is gases and dust can be dangerous in the workplace is in pharmaceutical manufacturing. So although it may not be one of the first industries that comes to mind when thinking about typical uses for hazardous area equipment, large parts of modern pharmaceutical facilities are classified as zoned hazardous areas. So this is due to raw solvents, chemicals and gases which are used during the manufacturing process, powders, dusts and gases produced as a byproduct of the manufacturing process, and then the storage of those raw materials on site for use during manufacturing. So in order to protect installations from potential explosion, a method of analysing and classifying a potentially hazardous area is required to ensure that the correct selection and installation of equipment. So the methods used to classify an installation can vary depending on which part of the world the equipment is located, but generally speaking, there are two main types of classification. So in countries that have adopted the IEC, which is the International Electrotechnical Commission philosophy, this is referred to as zoning, while in North American installations, they're classified by classes, divisions, and groups to ascertain the level of safety required. So for the next part of this webinar, we're going to concentrate on the IEC classification system. So the first element of classification we'll look at is defining the type of hazard. So this is done initially by subdividing the hazard into three types. Group 1, this is for mines and underground installations susceptible to fire damp. Fire damp being methane mixed with air in underground mines. Group 2 is for surface industries, so places other than mines, with potentially explosive gas atmospheres. And then Group 3 is for surface industries other than mines, with potentially explosive dust atmospheres. Group 2 can then be further subdivided into three gas groups, and this is according to the spark energy which ignites the most easily ignited mixture of the gas with air at atmospheric pressure. So this is known as its ignition energy. Now Group 2C gases require the least amount of energy to ignite the mixture at roughly 18 microjoules. So representative gases in this group are acetylene and hydrogen. We then go through to Group 2A gases, and these require the most amount of energy to ignite the mixture at roughly 260 microjoules. So gases included in this group are propane and petrol. So 2C is the most onerous group because it requires the least amount of energy to ignite it. And so equipment suitable for 2C gas group can also be used in 2B and 2A groups, whereas equipment only suitable for 2A can only be used in Group 2A, cannot be used in 2B or 2C. Group 3 is subdivided into three dust groups according to the properties of the dust particle. So Group 3C dusts are combustible and conductive dusts, such as magnesium. 3A is for ignitable flying, such as cotton lint. So same as gas groups, dust groups, 3C being the most onerous. If your equipment's suitable for 3C, then it's also suitable for 3B and 3A, but not the other way around. So as well as ignition energy, the other important consideration for explosive substances is ignition temperature. So this is defined as the temperature at which a substance can ignite and sustain combustion without being initiated by a spark or a flame. So sometimes incorrectly referred to as the auto ignition temperature. So substances can be grouped according to their ignition temperature. So for instance, hydrogen has an ignition temperature of 560 degrees C and so falls into the T1 class. while carbon disulfide has an ignition temperature of 90 degrees C and so falls into the T6 ignition class. So equipment can be classified according to these T-class ratings, and this is due to the maximum surface temperature a relevant surface can reach in normal operation. So equipment suitable for T6 class, the maximum surface temperature will not exceed 85 degrees C and therefore suitable for installation in a T6 class environment. Also suitable for installation in any one of the above ones from T1 to T5 because it's the most onerous equipment group. Whereas equipment suitable for T1 can only be used in T1 environments. So although every application is different, for the ease of monitoring and specification of each hazardous area, they're classified as a particular level or zone. So zones define the type of explosive atmosphere, be it gas or dust, as well as the likelihood of an explosive atmosphere being present. So the risk depends on how long the hazard is present. So as a result, all hazardous area equipment must be designed with hazardous area zone classifications in mind. As the zone governs the level of protection and precaution required, it is essential to know which zone you're working in so that you can specify the most appropriate equipment. So for gases, vapors, mists and dust, there are 3 zones. So zone 0 for gas or zone 20 for dust. These are categorized in the EPL category 1. And in terms of their probability of occurring, explosive atmospheres are present continuously or for long periods. So in zone 0 applications, typically the explosive atmosphere will be present for more than 1,000 hours per year. You then go into zone 1 for gas or zone 21 for dust, EPL category 2. And these explosive atmospheres are likely to occur in normal operation, but only occasionally, so between 10 and 1,000 hours per year. You then go into zone 2 for gas, zone 22 for dust, EPL category 3. In these situations, the explosive atmosphere is not likely to occur in normal operation, but if it does, it will only be present for a short period of time. So generally less than 10 hours per year. So let's take a little look at an example of a hazardous area and the different zoned areas on that site. So knowing which zone you need can be a challenge. So this is because every application is different and the site needs to be independently classified to determine things such as the types of gas and dust present, in what volume, and the level of ventilation on site. So ultimately, we always recommend that a hazardous area classification or a HAC needs to be done on site by qualified personnel by applying the standard 60079-10. But the level of protection provided by the equipment can vary, and therefore it's very important to make sure that you're using suitable luminaire for your application. This is by choosing your fitting based on suitability for the zone in which it will be located. So in this particular example we've got here is a petrol station forecourt. So zone 0 areas would be the storage tank on the vehicle as well as the underground storage tank under the petrol station forecourt. So you would expect to see a hazardous atmosphere being present in those areas continuously, and hence they are classified as zone 0. The zone 1 areas are around the fuel filler pumps. So when a customer comes in and fills their car, there'll be some fuel vapor being emitted by the fuel filler neck, as well as any spills around the fuel pump, and hence they would generally be classified as zone 1. So expected in normal operation, but for shorter periods of time. And then the area around the petrol station forecourt up to the canopy could be classified as a zone 2. So you wouldn't ordinarily expect a hazardous area to be present in those areas, but if it is present, it will only be there for a short period of time because of the level of ventilation on site. So next we'll take a little look at the system of classes and divisions used in North America for hazardous locations. So in North America, the class defines the nature of the hazard, and these are divided into Class 1 for gas, Class 2 for dust, and Class 3 for fibers and flyings. They are then further subdivided into divisions depending on the probability of ignition. So Division 1 being present under normal operating conditions, whereas Division 2 is only present during abnormal conditions and only for a short period of time. So a little bit similar to the zoning system in IEC, but not quite the same. Hazardous substances are then grouped into groups A through to G, depending on the properties of the substance. So I hope that's given you a little bit of an insight or a refresher into hazardous area classifications. In the next part of the webinar, we'll be looking at product certification. So strict certification requirements exist for any type of equipment being installed in hazardous areas, and there are several different certification schemes that exist in relation to hazardous equipment. The certification schemes relevant to you will depend on where the products are being installed. So this ensures that lighting and other equipment do not represent a safety risk and is compliant with the necessary regulations. Generally speaking, to obtain this sort of certification, the luminaire must be independently tested and approved by an independent third party called a notified body. So in the next few slides, we'll go into the finer details of these different certification bodies. So the first one you've probably all come across is IEC EX. Now this is the certification system based on the IEC 60079 series of standards, among others. And these ones cover electrical equipment used in hazardous areas. Now, IEC EX is an internationally accepted means of proving compliance with IEC standards. Product certification is carried out by an approved certification body, or an EXCB. So look out for IEC EX certification data, which manufacturers will generally publish on their website. So given that the IEC standards are used in many national approval schemes, IEC EX certification can often be used to support any specific national compliance in which it's required, often negating the need for additional testing in most cases. IEC EX also maintain the IEC EX database. This is a useful resource for many of you, as it allows you to publicly view the certificates of any product registered for use. So not just luminaires, but also includes power supplies, stopper plugs, for example. So this means that customers can corroborate the certifications given to them by a supplier. However, under IEC EX, it is also important to note that manufacturers' products intended for use in potentially explosive atmospheres, manufacturers must be assessed by an EXCB, and a quality assurance report, or QAR, is issued and is required to ensure that the manufacturer is authorized to produce and sell certain types of IEC EX equipment. So that's the international scheme. Whereas we'll then look at the ATEX scheme, which is the ATEX directive is the European certification that is mandatory across Europe, and like IEC EX is based on the IEC 60079 series of standards for electrical equipment. Also like IEC EX, ATEX involves all stages from manufacture through to installation and use of equipment. Certified equipment must be marked with the EX logo, and this logo should be included on the product nameplates, as well as the manufacturer's certification data and installation instructions on their website. So as with all other electrical equipment placed on the EU market, the product should also carry a CE mark. Now this shows that the product complies with all of the relevant EU directives, including the ATEX directive. And like IEC EX, under ATEX, manufacturers must be assessed by a notified body, but this notified body based within the EU. An ATEX Quality Assurance Notification, or QAN, is issued by the notified body, and it is required to ensure that the manufacturer is authorized to produce and sell certain types of ATEX equipment. Now, the next one we're going to look at is UKCA. Now, this is following the UK's departure from the European Union back in 2021. The United Kingdom Conformity Assessment, or UKCA mark, was planned to replace CE marking, and it declares that the product conforms to the applicable UK legislation in order to be placed on the market in England, Wales, and Scotland. Now, in the case of hazardous area equipment being installed in the UK, the ATEX directive was going to be replaced by the UKCA and the UK Directive SI 2016-1107. So this was going to be known as the UK EX scheme. So in addition to the notified body and QAN issued under ATEX directive and the QA issued under the IECX scheme, a separate UK-based approved body and UK QAN must be applied to products under the UK EX scheme. Now, I said was in that part of the webinar because last year the UK government declared an indefinite extension for businesses to utilise the CE mark and continued recognition of the CE mark within the UK. So essentially that makes the ATEX directive and certification a valid alternative marking to employ as well going forward. So I've mentioned the 60079 series of standards quite a bit over the last few slides. So these relate to IECX, ATEX and UK EX schemes. So it's worth giving a brief overview of some of the standards and how they relate to equipment protection concept. Now the top one there, 60079-0, these are the general requirements for electrical products must comply with. Products will then use a protection concept or combination of concepts outlined in the other series of standards to provide an overall compliant product. So for instance, 60079-1 provides the requirements for flame-proof enclosures. So this is where an enclosure is capable of withstanding an internal explosion without transmitting the products of that combustion to an outside atmosphere and hence providing an ignition source for an explosive atmosphere. Whereas 60079-7 or EXE, that's increased safety, where measures are taken within a product to prevent sparks and excessive temperatures from being able to provide a source of ignition. So as you can see on that table, there's many different types of protection concept for electrical equipment. So it's important to be familiar with these concepts when using hazardous area equipment. So the last one we're going to look at is the system in place in Canada and the United States, which generally speaking do not base national compliance for hazardous area electrical products on the 60079 series of standards. Instead, a separate range of UL and CSA standards exist in which the product must comply with. So equipment placed on the market in the US and Canada must be tested and certified by a nationally recognized testing laboratory, or NRTL. Now this NRTL ensures compliance with the relevant standards in line with OSHA, which is the Occupational Safety and Health Administration. So in the case of Raytech, we work with our NRTL Met Labs, and our products bear the Met mark, indicating that the product has met the minimum requirements of the applicable safety standards. Additionally, the Met mark validates the product's continued compliance to these standards as evidenced by periodic factory follow-up inspections. So similar to QAN, QA, UK QAN, we also undergo periodic factory inspections as part of our NRTL listings. So having discussed all that in some detail, let's look at the EX equipment nameplates. So an EX luminaire's nameplate provides valuable information about the equipment. So it allows you to identify the manufacturer, the areas in which it is safe to be used, as well as information about the luminaire specification. So information about luminaire specification, including input voltage, ingress protection rating, and much more. So for installers and end users, this information is absolutely critical to ensuring that the luminaire is installed correctly and safety on site is maintained. So to understand the different information on a nameplate, we'll look at an example of one fitted to one of Raytek's Spartan mid-power flood luminaires. So the look and layout of a nameplate will vary depending on the manufacturer. However, this is a typical example of the markings that you would expect to see from a luminaire that has been certified for use in hazardous areas. So if I take you through it step by step, so top left corner, you would find the name and address of the manufacturer. So in this case, Raytek Limited, based in the UK. We next then see the WE logo, so that is to encourage responsible disposal of electrical equipment within the EU and the UK. Next, we'll see the UKCA mark and the number of the approved body responsible for monitoring the quality system under our UK QAN. Next to that is the CE mark and the number of the notified body based within the EU responsible for monitoring our ATEX QAN. Remember, that's our quality assurance notification. Next, you'll see the description of the certified equipment. So in this case, mid-power Spartan LED luminaire. Underneath that, the certificate numbers of the certified equipment. So this is particularly important for being able to view the certificates of the product and see any special conditions of safe use, for instance. So certificate numbers of certified equipment for ATEX and ICX and UKEX. And as we've said there, some equipment may end in a U for component cert or end in an X, meaning that that equipment has some special conditions of safe use. So it's important to know the certificate numbers so you can then refer to those certificates. The ambient temperature range for the certified equipment is listed next. So in this case, -40 to +60. And the cable gland thread entry size. Moving around the plate, serial number of the equipment, including the year of manufacture, part number of the equipment, any other essential information that might be required by the standard, so do not open when energized, voltage range and power consumption, so you can ensure that you're putting the correct voltage input into the product. Moving around, we then see the ingress protection rating, so IP66, IP67 for this particular luminaire. So if you remember your IP ratings, the first letter is protection against the ingress of solid objects. So in this case, 6, meaning dustproof. And the second number is protection against the ingress of water. So 6 against powerful water jets, 7 against immersion to a certain depth. And finally, you'll see the explosion protection markings. So this is also critical for understanding how the product has been designed for safe use and what zone it is suitable for. So in this case, Group 2, meaning surface industries, suitable for gas environments. Category 2, meaning Zone 1 applications. GD for gas and dust. EXEB, so increased safety to the level of protection B. MB, meaning encapsulation to the level of protection B. 2C, meaning for suitable for installation in 2C gas groups. T4 rating, meaning ignition temperature in category T4. And GB for gas to level of protection B. Underneath that, you will see the dust markings. So EXTB, meaning protection by enclosure to the level of protection B. 3C for 3C dust group, and T90 degrees C. That means the maximum surface temperature in worst case ambient will be 90 degrees C, and therefore you can glean from that the ignition temperature of any relevant dusts in the atmosphere. So we mentioned EX certificate numbers and the potential to see an X on the end of that certificate. So it's important to know why an X might be used and to look out for the X symbol on a certificate. So it identifies there is a specific condition, whether that is to do with the installation or the maintenance of the equipment, and it should be considered when using the equipment in hazardous areas. So this X would be found on the end of a certificate number, as well as within the installation guides and manuals for the product, and it must include explanations of what the X conditions are. So an X doesn't necessarily mean something bad about the equipment. It could be something as simple as how to clean the equipment safely, but it's important that this information is shared to ensure that the equipment is safe to install, use and maintain within a hazardous area. So where does self-certification fit into all of this? So self-certification is a widely accepted principle in non-hazardous applications. So for the purposes of UKCA marking and CE marking for ordinary location industrial applications. So in these situations, manufacturers are asked to declare conformity to the relevant directives and applicable standards for their products. So manufacturers must create and maintain a technical construction file, and this should be made available to authorities if required to prove compliance. Now under IECX, ULCSA and ATEX for Zone 1 products, there is no scope for self-certifying electrical products for use in potentially explosive atmospheres. Certification must be carried out by a notified body and a QAN or QA issued to the manufacturer. Conversely, for Zone 2 products under the ATEX scheme, there's actually no involvement by a notified body. All manufacturers declare conformity to the relevant standards when placing products on the market. So a manufacturer can choose to self-assess their products against the requirements of the relevant standards, and in those situations would be solely responsible for the safety assessment of the product. Now, obviously, with this approach comes an increased risk of non-conforming products being placed on the market. And in these situations, a greater onus and element of risk on the part of the distributor and the end user to confirm the suitability of the product for the application. So things you've got to ask yourself is, if a manufacturer has self-assessed the product, has it been fully assessed against the requirements of the standard? Have they potentially missed any small details which might be critical to the safety of the product? What about the continued quality and surveillance of the supply chain and manufacturing? Has the product even been assessed against the latest versions of the standards? So for instance, AXNA is no longer a protection concept in the latest versions of the standards, having been replaced by AXEC. So buyers really need to ask themselves these questions when purchasing products that have been self-assessed. Our advice is choose a luminaire that has been certified by a third party. And this is the approach that we take at Raytech for all of our products, including Zone 2 products. They're all certified by a third-party test lab. So I'll move on to choosing the correct luminaire. So why certified LED lighting? So it's not only important for ATEX directive and hazardous area certification, but certified lighting is also essential for safety and quality on site, but it's not the only factor to consider. So luminaires must also meet other important directives. So these include the low voltage directive, the electromagnetic compatibility directive. So standards apply to ensure the safe operation in terms of electromagnetic compatibility of luminaires. Some luminaires also fall into the Eco Design Requirements Directive, and we also need to consider the REACH and ROACH directives as well, so the reduction of hazardous substances. So all of these directives apply to lighting products as well as the ATEX directive. So what is the RATEC approach overall? So we always ensure that our products are certified to the latest standards. So that includes Zone 2 luminaires. We prioritize independent testing for all our luminaires. So that ensures reliability and safe operation in hazardous environments. We also maintain IECX, ATEX, UKEX and ULCSA certification for all of our products. And we do hold QAN, QA, UK QAN and factory inspections for ULCSA for all of our certifications for our production facility in the UK. So all of this combines ensures safety and reliability on site. So in summary, when specifying equipment for use in hazardous areas, end users should choose equipment based on the specific requirements of the site. It is vital that end users are aware of the key considerations when specifying. So you need to be thinking about the zone that you are specifying in, so you can specify the most appropriate equipment. You need to know where the products are being installed and the certification requirements in the local area to ensure that the product is compliant with the necessary regulations. You need to know the method of protection used during certification, so you're clear how the luminaire has been designed and therefore will need to be maintained in the future. You need to know the type of hazard and identify the risks of ignition and the severity of an explosion. So this allows the correct selection of equipment for that specific hazardous area. And when it comes to product testing, RATEC prioritizes independent testing, ensuring the safety and reliability of hazardous environments. So overall, follow this general rule of thumb when specifying your hazardous area equipment. You can rest assured that the site is protected to the highest possible standards. So thank you very much. That's the end of the slides. Is there any questions?
Brill, thank you, Jonathan. I think that was extremely useful, and I hope everyone found that useful who was on the webinar. So we've just had a few questions come in there. So one being, I noticed that you have the EXTB on your nameplate. What does the B stand for? Jonathan,
Right, okay. So yes, on the nameplate walkthrough, we had EXTB, which was our concept for protection against dust. So EXT is protection by enclosure. So our products have a protective enclosure that prevent the ingress of dust, so IP6X, and then ensure that the maximum surface temperature do not exceed certain levels to prevent an ignition of the dust. The B in that code is the level of protection. So for B would refer to a level of protection suitable for Zone 1 equipment. So it's also found in the increased safety standard as well as encapsulation standard. So B meaning level of protection B for Zone 1, C being level of protection C, which would be suitable for Zone 2 luminaires, but within the same standard.
Brill, thanks, Jonathan. We've just got a few more coming in here. So Brian asks, I'm starting to hear more about fake equipment. Have you come across such equipment?
Yes, well, I haven't personally come across such equipment, but yes, I've heard a lot of talk in the industry. Some of our distributors and industry colleagues have been running their own webinars on fake ATEX equipment and fake certificates on the market. It does appear to be a growing problem. There's some excellent resources and webinars in the industry going around that you can find out more information about that. But as a manufacturer, we haven't personally come across any fake equipment, but we know people who have out in the field.
Brill, thank you. So Sean says, great presentation. Could we maybe have a separate slide just for item 14 on the nameplate? So Sean, we can, yeah, we'll be able to pull that slide together after the presentation. Yeah, and send that across. We've got a couple in about we received the copy of the presentation. So yes, we'll send you a copy of the slides, and we'll do a full follow-up probably the day after the presentation with some copies of the slides and everything. So yes, you'll receive that. Couple more in here. Is there a minimum requirement for IP rating for equipment protection? That's another question there, Jonathan.
Yes, there is a minimum requirement. It does depend on which protection concept you're utilizing. So I mentioned the EXT, protection by enclosure. So really the minimum IP rating for that protection concept would be 6X, so dust tight. For increased safety, the minimum IP rating is IP54. But you also need to really apply the intended application of the product. So an IP54 luminaire, while being the minimum requirement in the standard, wouldn't necessarily be suitable for the application you're putting the product in. So our products are often used outdoor in very onerous conditions. So most of our products are IP66, 67, which do exceed the minimum requirements of the standard.
Brill. So Marcel's asked, some manufacturers do not have the X behind the certification number because they explain the X in the installation manual instead of the certification document. Is this allowed?
Yeah, so it depends on the type of special conditions of use. So so some of our products, as you've seen on a nameplate, require the product to not be open when energized or being cleaned with a damp cloth to prevent the buildup of static. But those products do not carry an X on the certificate, whereas other products may carry an X for such things as ensuring they're installed in areas of low risk of mechanical impact. So in that case, an X would be present on a certificate because that gives you a specific details about how a product should be installed. So the answer really is it depends, unfortunately.
So there's another one here. It's got a fair few questions in. What is the major difference between the IECX and the ATEX standards for hazardous areas?
Well, actually, the standards themselves are identical. So so they're all harmonized standards. So the IEC 60079 is largely the same as the EN versions of the standards, which are largely the same as the BSEN versions of the standards. There may be some very slight variations within national bodies, but overall the standards are the same. The actual applicable directive just depends on where you're placing the product on the market. So ATEX is a requirement within the EU. As I said, UK EX or ATEX is still applicable for the UK, and then the rest of the world, IEC EX is the suitable certification body, but the standards are largely the same. So you'll often find luminaires being tri-rated or dual certified for both. Well, as the case with all Raytech products, the same product will carry IECX certification, ATEX certification, and UKX because the standards are identical.
Brill. I think that's majority of the questions. If we've missed any questions, we will come back to you offline. Let's see if there's any more. There's one that's just come in. So when the hazardous area classification product is opened by a customer, does that void the certification?
No. So periodic inspections are required on site for all hazardous area equipment. So that could be a visual inspection or a close inspection. And if a customer or end user was doing a close inspection, they would be expected to open the luminaire. So no. Yeah, products are designed to be opened and inspected on site. But obviously the special precautions have to be taken when doing that, and only by competent personnel.
Real. Right, I think that might be all the questions that I can see.
Okay.
One more that's just popped in. Can the EXD light be used again after repairing?
So, well, it depends on what has been repaired. So, if there's EXD referring to a flameproof enclosure. So modifications are not allowed to a flameproof enclosure by anyone other than the manufacturer. So if there's been damage to a flame path or somebody has drilled a hole in a flameproof enclosure, then absolutely that equipment is no longer safe. It's potentially able to be repaired, but only by the manufacturer or authorized representative.
Right. Yep, I think that's all the questions. So if I have missed your question, we will come back to you offline. But yes, so that'll be the end of the webinar. We will stay around for a couple more minutes just to see if there's any more questions that come in. But if not, thank you to everyone who's joined us today, and I hope you found this webinar useful. We will send you the webinar slides as well as the recording will be on our website most likely tomorrow. But yes, we will send everything over. But yeah, thank you again.
Yes, thank you everybody, and thank you for your questions.